So you can revise your angular velocity, just read out the definitions in your mind and just glance the formula once. I've already taught this. Just see the slide once and try to remember the formulas and the definitions. And what I have explained. I've also given you some questions, so try to recall them. You even made mistakes. Okay. Enough time for recalling. We shall move ahead. Did I teach you the relation between frequency? Yeah, I taught you this. The relation between frequency and the time period. Omega, angular velocity, is equals to omega, your angular velocity is equals to 2 pi f. Okay, this relation is important. This is your angular velocity, omega. This is your frequency. Now, this is your, what is this? Yeah. Relation, there are two different formulas of omega. First one being omega is equals to theta upon t, where theta is your angular displacement. I'm talking about this, where theta is your angular displacement. So theta upon t is one way of finding angular velocity, one way of calculating. The other way is omega is equals to 2 pi by t. Okay, where this 2 pi simply signifies an angle or an angular velocity only in the form of, because I've told you the SI unit of angular velocity, angular displacement is radian, and 2 pi radian is equals to 360 degree. I've told you this relation as well between the radian and the degrees. So 2 pi rad, 2 pi here signifies a certain amount of distance covered or an angular displacement only divided by the time period t. So this is a modification of the previous formula, just modification of the previous formula. So do I have a space for giving? Okay, this also I explained you. What is dl into d theta upon r? I've told you a relation between the circumference length, that is equals to radius times your angular velocity. Radius times your angular velocity, angular displacement. Now your same thing is with your linear velocity. Linear velocity v is equals to angular velocity times radius. This is also a relation between linear velocity and angular velocity. These are the things for your recall. Moving ahead, uniform, before starting uniform circular motion, let us solve some questions. Let's solve some questions. Okay, this is a simple question I'm giving you guys because it is necessary just to check whether you have understood the concept about relation between frequency and time period. ठीक है, तो एक क्वेश्चन कर लो छोटा सा. क्वेश्चन है कि the angular speed of a flywheel is making no, this is not the correct language. A flywheel which is making, this will be the correct language, which is making 120 revolutions per minute Okay, you have to calculate what? Angular speed. And what is given to you? What is given to you is your frequency. Revolution per minute. I've told you how do we define frequency? SI unit for frequency is, okay, do you see this frequency? SI unit for frequency is revolution per second. Revolution divided by seconds. So if you'll convert minute into seconds, this is a type of frequency only, and the frequency is given. I've also showed you the formula. Quickly try to solve it and give me the answer for this question. The angular speed of a flywheel, which is making 120 revolutions per minute. What will be the angular speed? Okay. And everybody just please give me correct answer for this question. Very simple question. Very, very simple question. 1 minute time to you. Hmm. Let me see the chat box. 12.56 rad. Okay. Good evening. Sapna has joined after a long time. But Sapna क्यों इतने दिनों से छुट्टी पे थे आप? Anyways, good evening. और बिना रीजन के बेटा छुट्टियां मत करा कीजिए. आप शायद लास्ट क्लास में थे नहीं, इसलिए मैंने आपको बताया नहीं. एक हफ्ते से ज्यादा जो बिना बताए छुट्टी करेगा उसको एकेडमी से बाहर कर दिया जाएगा. ठीक है, तो बिना बताए छुट्टी नहीं करनी है. किसी एक टीचर को इन्फॉर्म करेंगे आप, और एक को क्या, जिसकी क्लास होगी आप उसको ही इन्फॉर्म कर दिया करिए. ठीक है, आप ग्रुप में मैसेज लिख सकते हैं. 12.56 rad. Only one answer. Others, are you not trying? इसमें क्या ट्राई करना? If you guys are not able to solve this question, then I think there is some serious problem with the concepts, because it's very easy question. ठीक है, इसको नहीं कर पा रहे हो. प्रतिभा ने चलो क्लास नहीं अटेंड किया था शायद लास्ट क्लास. रिकॉर्डिंग भी देख कर नहीं आई होगी एज एक्सपेक्टेड. And Sapna bhi nahi hai, and Prasanna has also not attended last class. That is why I guess nobody other than Malini is able to solve this. Okay, I'll write the solution. Don't worry. Just try to understand the solution if you are not able to solve the question. The question has given you frequency f, which is equals to 120 revolutions. Then it is given in the form of per minute. Always remember, frequency, SI unit for frequency is in revolution per second. Okay, it is revolutions per second. So it is per second, but it is given you in the form of minutes. So what you will do, will convert 120 upon 1 minute into 60 seconds. Okay, it was 120 upon 1 minute. You will convert this into 120 upon 1 minute. How many seconds are there? 60 seconds are there in 1 minute. So, oh, not 60. Let me just erase. So 120 upon 60. Okay. Now this is 120. What is 120? These are your revolutions. What is 60? This is your seconds. So frequency is equals to 120 by 60. That is equals to, if you simplify, this will come out to be 2. Okay. Frequency given to is 2. And what are they asking? They are asking angular speed. Angular speed is denoted by omega, and omega is equals to 2 pi f. Okay. So your answer for omega will be simply 2 pi. This is the formula. Omega is equal to 2 pi f. Relation between angular speed and frequency. This formula gives you relation between your angular speed omega, what is asked in the question, and the frequency और angular speed के बीच में ये formula से relation आता है. Omega is equals to 2 pi f. तो omega is equals to 2 pi f की जगह आप 2 रख देंगे, तो your final angular velocity omega will be 4 pi radian per second. Okay. So that's how you solve it. और इसमें पाई की वैल्यू रख के मलिनी ने आगे भी सॉल्व कर दिया है. So that is also good. So your Malini, your answer is also correct. Very good. But that's how you solve these kind of question. Okay. Do you guys want me to give you another question for this? Another question of this type. A very simple another question. This is the answer to the previous question. I'm giving you next question right here. The next question says two particles having mass capital M and small m are moving in circular path. Circular path having radius capital R and small r. Okay, there are two particles. The question says there are two particles, दो particles हैं. एक particle का mass m है, one particle is having mass capital M, one particle is having mass small m. That is, they are having different masses and they are moving in a circular path of different radius. That is they are moving in different circular paths. Okay, so the first path is with radius capital R and the second path is with radius small r. If the ratio of their time periods, if the ratio of their time period of what? Time period of completing a revolution around of the circular path. If the ratio of their time periods, the ratio of time periods for both particles is same or is equal to 1, then calculate. Very simple question again. Try to understand the language of the question, try to follow what question is asking, and try to use the formulas which I've revised in the starting of the class. Okay, I'm not giving you anything new. कुछ नया नहीं करा रहा हूं मैं. जो आप लोगों ने पहले पढ़ रखा है ना, जो फॉर्मुलेज मैंने अभी दिखाया आपको क्लास स्टार्ट करते टाइम, जो फॉर्मुलेज मैंने दिखाया उन्हीं के बेसिस पे सारे क्वेश्चन सॉल्व होंगे. So you have to calculate the ratio for angular velocity. Velocity लिखना भूल ही गया मैं. Angular velocity. It's the ratio for angular velocity. ठीक है. I hope the question is clear. Two particles having different mass capital M and small m are moving in two different circular paths having radius of a capital R and the other one is having radius of small r. If the ratio of the time periods for both the particles to complete one complete revolution in their respective circular paths is equal to 1, then calculate the ratio of angular velocity. Okay, that's the question. And 1 minute time again. Again 1 minute time. Try to solve. Deepika has joined. Okay. Pratibha has left. Deepika has joined. Okay, try to solve this question. Again 1 minute. Okay, last question for this. I will then start a new topic in circular motion. Okay. Its ratio is 1. Okay, Malini has answered. 1 pi rad per second. 1 pi rad per second. Okay. Prasanna has also answered. Okay, good. Out of 4, 2 has answered. Very good. Both of you are correct, but I would like to just simply tell you, Pratibha, that you are more correct because sorry, not Pratibha, Prasanna, because you have also mentioned the unit. So Malini, you should keep this in mind, that mentioning unit is important. Anyways, the concept here is, concept kya hai? The concept which lies here is that omega, angular velocity, is equals to 2 pi by t. We have read this formula. Okay. Okay. Now this formula does not include any terms of radius, okay, or the mass of the particles. You can see the formula very well. This formula includes no term for mass of the particles which are undergoing the circular motion, and it also does not include any term for the radius of the circular path. ठीक है ना? ना पार्टिकल के मास के बारे में कोई टर्म है इस फॉर्मूले के अंदर, ना कि सर्कुलर पाथ जिस पर मोशन हो रहा है उस पाथ का कितना रेडियस है उससे रिलेटेड कोई भी टर्म है। तो हमें मास और रेडियस की कोई जरूरत ही नहीं है। अगर मास और रेडियस अलग अलग रेशियो में है भी तो भी हमें कोई फर्क नहीं पड़ता एंगुलर वेलोसिटीज पे। The main thing this angular velocity omega depends upon is time period, because 2 pi is a constant number, 2 pi is a fixed number. The only thing which angular velocity depends upon is time period. Okay, time period is time taken by the particle to complete, है ना, one complete circle to to take one complete circle around the path. ठीक है. So if the ratios of the time period are same, the ratios of the omegas angular velocities will also be equal to 1 upon 1, that is 1:1. Okay. This was a very simple concept which you guys did very happily. Next. Okay, let me just sum up the uniform circular motion. Uniform circular motion, what you have read about uniform circular motion, angular acceleration is left and centripetal acceleration, this will come later. Okay, we'll talk about this, don't worry, we'll talk about this. But for now, just summarize what do you mean by uniform circular motion. If you are moving in a circular motion with uniform velocity, with uniform speed, okay, uniform angular speed, then your circular motion is set to be uniform circular motion. That is, you are undergoing the whole circular motion with a fixed speed, okay, which is angular speed is denoted by the alphabet omega. It is constant throughout the uniform circular motion, okay, and the time period to undergo the circular motion is calculated by t is equals to 2 pi by omega. Because how did this formula came? Omega is 2 pi by t. Omega is what? 2 pi by t. So from here, if you transfer t here and omega to this side, you will get t is equals to what? 2 pi by omega. So that's a simple exchange of terms to calculate this formula. So it is self-explanatory formula. Frequency. I've already told you this very important relation about frequency, that the frequency of a particle undergoing circular motion is inversely proportional to its time period. Frequency is equals to 1 upon time period. Okay. So time period is omega 2 pi by omega. 1 upon time period will be omega upon 2 pi. If time period is equals to 2 pi by omega, then 1 upon time period will be obviously omega will come on top. Omega will come on top and 2 pi will come on a denominator. So frequency will be omega upon 2 pi. Centimeter acceleration we'll talk about in the coming topics, but I hope uniform circular motion is clear. Now let me teach you a very basic analogy, not non-circular motion. Non-uniform circular motion will come later. And that acceleration is here, which is good. Okay. First of all, let me revise you the three formulas for circular motion. You can also say relationship between angular velocity. This is we have already done in the previous slide, but just you should know, have a clear idea about these relations between angular velocity and linear velocity. Okay, angular velocity is represented by the alphabet omega, and linear velocity is represented by the alphabet. What alphabet? Linear velocity is simply represented by the alphabet v. So v vector. Okay. Now there are three simple relations which we have already done, but just to make you revise, I'm telling you. And these are only applicable in circular motions. Okay, these are only applicable in circular motion. The linear velocity v is equals to radius times omega, and the other form of writing this is the vector form. V vector is equals to radius position vector cross multiplied by your angular velocity. Okay, this is the vector form of writing. This is the scalar form. This is your scalar form. Scalar form and vector form should be clear by now. We have studied the whole chapter. Vector, this is vector form. Okay. Now we need to understand one simple thing, or not simple thing, one important thing here, that this v we are telling this v as whole, that this v is representing the linear velocity. ठीक है, हम बोल कह रहे हैं कि जो v अल्फाबेट है ना, ये linear velocity को रिप्रेजेंट करता है इस रिलेशन में. ठीक है, this is what we are telling you, that this alphabet v is representing linear velocity in this relation. But what actually, or what is the more correct answer is that this formula is more true when I write v perpendicular is equals to r omega. Okay, this formula v is equals to r omega is valid for circular motions, but for all other motions which are not circular, for all other motions, these other motions you will read in the 7th chapter, which is your system of rotation bodies. ठीक है, उस वाले 7th chapter में आप in other chapters, you will read about these other motions which are not circular, but in which you have to use the relation. But In those motions, there will be angular velocity as well as linear velocity, but those will not be circular. Okay, so for all other motions, all other motions, today my speed is not that good. I feel V perpendicular is equals to R omega. Now, why I've written V perpendicular is equals to R omega? What does this indicate? This simply indicates the perpendicular component of velocity. Perpendicular component of velocity. Okay, this relation is applicable for all the other motions outside of the circular motion. In all the other motions, the angular velocity cross multiplied by the radius will be equal to what? Will be equal to what? Your perpendicular component of velocity, which is, sorry, linear velocity. I forgot to write the word linear, but now I'll write this here. This is the more correct form. This is the more correct form. Okay, more correct form. I will explain you this thing deeply when we'll study about centripetal acceleration. Why I am writing V perpendicular is equals to R omega, and what is the meaning of V perpendicular into R omega? Velocity, you see, velocity has two different components. Okay, whenever you are first, let's take example of circular motion. When you're moving in circular motion, velocity has two different components. Velocity, if you're moving like this, the velocity, net velocity will be in this direction. If you're moving in a circle like this, if you're moving in a circle like this, like this. So at this point, your net velocity is in this direction. Okay, but this is due to two components, which is one is your perpendicular component and the other one is your radial component. One is your perpendicular component and the other one is your radial component, like this. If this is the not this, let me draw a bigger circle. Don't worry, when I will explain centripetal acceleration, I will explain this point more deeply, but just understand that inside a circular motion, a linear velocity has two different components. Okay, the first one is your along the radius of the circle. This is the radius of the circle, this is the radius of the circle. So first component will be along the radius, this is VR, and the other one will be perpendicular to this radius. This is your V perpendicular component. This is the perpendicular component of velocity. Perpendicular to what? Perpendicular to the radius of the circle. Perpendicular to radius of the circle. Perpendicular to what? Perpendicular component of velocity, but perpendicular to what? Perpendicular to radius of the circle. This is what you should remember and what you should understand from this point. And how do we see application of this point? Okay, this I will teach you when we are doing centripetal acceleration in detail. Okay. For now, just understand that V perpendicular is equals to R omega is the more correct form. Okay, is the more correct form of writing relationship between linear velocity and angular velocity for all the other motions instead of circular motions. For circular motion, you can write V is equals to R omega, but for all other motion, you should specifically write this symbol of perpendicular. Okay, then only this formula is valid, and it's not valid in other cases. Okay. Let me just give you a question. Can I give you a question? Yes, I can give you a question. Okay. Let me just ask you. Are you guys? So screen visible नहीं है, ना voice आ रही है, visible at my side and audible. बेटा दीपिका, I think आपको rejoin करना चाहिए. इसको voice भी नहीं आ रही ना. ऐसा कुछ होता है तो अपने आप rejoin कर लिया करो. Yes, Malini, you gave a hand request, raise, and then you took it off. क्या हुआ है? You want to say something? Okay, good, दीपिका, good. Malini, कुछ कह रहे थे बेटा आप? अच्छा, कोई बात नहीं. But did you understand the simple relation between the linear velocity and the angular velocity? Just tell me if you are clear, and till then I'm giving you a question. The question is, a body is whirling. Do you understand? Yes. You will not understand the word whirling. Is undergoing a horizontal circular path of radius 20 centimeters. It is it it is having an angular velocity of 10 rads per second, of 10 rads per second. What will be its linear velocity? What will be its linear velocity? Okay, very simple question based on the formula I just taught you. At a point on circular path. Okay, because this obviously the relation between linear velocity and circular angular velocity will be in circular motion. So at any point of circular path. Okay, so the question is pretty clear. I suppose the particle is undergoing a circular motion and the radius of the circular path is 20 centimeters. You have to calculate the angular velocity omega. Okay, and sorry, it is having an angular velocity omega which is equal to 10 rads. You have to calculate the linear velocity. Okay, angular velocity is given to you. You have to calculate linear velocity, and what is else given to you? Radius of the path is given to you. So simple multiplication is there. Just multiply and tell me the answer. How much will be the linear velocity? Quickly. Okay, time up. Let me see who is able to solve this. Who is able to solve this simple question? 20, 20 or 200 centimeter per second. Okay, Malini again. Meter per second होती है velocity की SI unit. So there's no need to answer in centimeter per second, but sorry, not a problem if you've answered in that. This is correct. Everybody now. I hope everybody has. But Sapna answer is how can answer 20 कैसे है? 2 होगा ना बेटा answer. Let me just solve it. 20 कैसे आ गया आपका? आपने एक 0 extra लगा दिया है. Radius is given to you 20 centimeters. Velocity is always in meter per second. So convert this 20 centimeters into meters. So 20 upon 100. Okay. So linear velocity V is equals to R. So this is your R multiplied by omega, which is 10. So it will be 2 meters per second. Okay, to simply you have to do 20 upon 100 into 10. ये करना था. हाँ सपना.
हेलो
हाँ सपना.
सर 2 आएगा, वो मैंने गलती से लिख दिया.
कोई बात नहीं बेटा. ओके, एक और क्वेश्चन करना है. क्या एंगुलर एक्सेलरेशन बढ़ते हैं. इट्स enough questions for today. Angular acceleration. So the term angular acceleration is same as linear acceleration. Sorry, the basic meaning of acceleration remains similar. I want to say the basic meaning of that word acceleration remains similar. What is the meaning of word acceleration? Change in the velocity. When we used to talk about linear acceleration, it was due to change in linear velocity. When we are talking about angular acceleration, it will be due to change in angular velocity. Simple सी बात है ना. लीनियर एक्सेलरेशन हम क्या बोलते थे, जब किसी पार्टिकल की चलती हुई वेलोसिटी में चेंज हो रहा है. भाई 10 से चल रही है, बढ़कर के 20 हो गई, तो वेलोसिटी में चेंज आया, तो उससे इसलिए इसका रीजन क्या होगा, एक्सेलरेशन होगा. इसका रीजन एंगुलर केस में भी होता है. एंगुलर एक्सेलरेशन के केस में क्या है कि भाई एंगुलर वेलोसिटी के केस में चेंज आ गया. अगर एंगुलर वेलोसिटी 10 राड पर सेकंड थी, बढ़कर के 20 राड हो गई, तो चेंज आ गया. तो एंगुलर वेलोसिटी में भी चेंज आ रहा है, वो एंगुलर एक्सेलरेशन की वजह से आ रहा है. सो एंगुलर एक्सेलरेशन बेसिकली इज द चेंज इन योर एंगुलर speed. So they have written speed of the particle is variable. Okay, there are two types of angular acceleration. One is tangential angular acceleration, and the other sorry, there are two types of acceleration. The one is tangential and the other one is angular. इसको break down करके समझेंगे what is tangential acceleration and what is angular. You can understand by the word tangential and angular itself. Tangential, what is the meaning of the word tangential? Tangential का मतलब होता है सर्कल के along, sorry, circumference के along किसी point पे अगर आप draw करें तो उसको टेंजेंट बोलते हैं. जैसे सपोज ये सर्कल है, वे इसमें मार्कर ही रहा, ये एक सर्कल सर्कमफेरेंस का एक पॉइंट है. द पॉइंट ऑन सर्कमफेरेंस. इफ आई ड्रॉ a straight line passing from this point, this is not a straight line. First of all, if I draw a straight line, suppose करो, if I draw a straight line touching this point and passing through the circle like this. Okay, suppose it is touching. Suppose को touch करे, अभी इस केस में touch नहीं कर रही है, but suppose okay, this point, let me take this point. A line is coming and just touching the circle and passing. आज touch नहीं होगी line. Okay, it's just touching the circle on one point and passing. इसको this is called tangent. Okay, so tangent बोलते हैं जब circumference पे एक point को touch करके एक straight line निकल जाए, उसको tangent बोलते हैं. ठीक है. तो इस tangent, इस ऐसे कई सारे tangents possible हैं, क्योंकि circumference पे सोचो कितने सारे points आप ले सकते हो. So you can take infinite number of you can have infinite directions for tangential acceleration. But angular acceleration will be in a fixed direction. Why? Because it is an axial vector. It is an axial vector. In the direction for angular acceleration will be same as the direction of angular velocity. ठीक है. How do you determine the direction of acceleration? Direction of acceleration is determined by the direction of change in velocity. ठीक है. तो जो direction आपकी change in velocity की होगी, that the same direction will be for your angular acceleration. Okay, so you have to just check the direction for change in velocity, which is by the right hand thumb rule. I have explained already in the previous class. Curl the fingers of your right hand in the direction of movement. ठीक है. If you will curl the fingers of your right hand in the direction of movement of the particle, then the thumb will give you the direction of angular acceleration. ठीक है. So angular acceleration alpha is an axial vector. Okay, angular acceleration is represented by another Greek alphabet alpha. Another Greek alphabet alpha. इससे represent करते हैं angular acceleration को. Now, angular acceleration, what was acceleration? Change in velocity. So angular acceleration will be change in angular velocity. So another formula for angular acceleration is change in angular velocity. So d omega by dt represents what? The omega is your angular velocity, d omega by dt is change in angular velocity. Okay, so change in angular velocity. This is the formula. Tangential acceleration is related to angular acceleration by this relation. ठीक है. What is this relation? AT is your tangential acceleration. The acceleration along the tangent is equal to the angular acceleration. Okay, this will be the direction of angular acceleration. This will be the direction of angular acceleration. This, and this is the direction of a tangential acceleration. This. So they are saying that the tangential acceleration is related to your angular acceleration by this formula. That is angular acceleration times radius is equal to tangential acceleration. Okay, ये चीजें clear है. Now what are omega 1? Next point is, if omega 1 and omega 2 are the instantaneous angular velocities at time t1 and t2 respectively, then the average angular acceleration is calculated by change in angular velocities omega 2 by omega 1 upon t2 minus t1. Also self-explanatory thing. These all points are self-explanatory. You know what is the condition. They are given you two different angular velocities. First one is omega 1, other one is omega 2. दो आपको angular velocities दे दी. क्या बोला, ये इंस्टेंटेनियस एंगुलर वेलोसिटीज हैं. ये इंस्टेंटेनियस मतलब किसी पर्टिकुलर इंस्टेंट की एंगुलर वेलोसिटीज हैं. किस इंस्टेंट की हैं? एक ओमेगा 1 है आपकी t1 टाइम की, और ओमेगा 2 जो है आपकी t2 टाइम की है. ठीक है, ये बोला आपको. अगर आपको दो इंस्टेंटेनियस एंगुलर वेलोसिटीज दे दी जाती हैं अलग अलग टाइम, मतलब अलग अलग टाइम इंटरवल्स पे, और आपसे पूछते हैं एवरेज एक्सेलरेशन बताओ, तो आप क्या करते हो? फाइनल माइनस इनिशियल अपॉन टोटल टाइम फॉर द चेंज. ठीक है, मतलब कैसे निकालते हो? अगर मैं बोलूं 10 मीटर पर सेकंड पे आप चल रहे थे और आपकी स्पीड बढ़ गई 20 मीटर पर सेकंड हो गई इन 2 सेकंड्स, तो आप क्या बोलोगे? टोटल चेंज कितना आया सर? फाइनल माइनस इनिशियल. फाइनल थी हमारी 20, स्टार्टिंग में हमारी थी 30, अपॉन टोटल टाइम लगा सर 2 सेकंड, तो सर हमारा एवरेज एक्सेलरेशन हमारा हो जाएगा, एक्सेलरेशन एवरेज विल बी चेंज इन वेलोसिटी अपॉन टाइम. ये फॉर्मूला आपने थर्ड चैप्टर में पढ़ा हुआ है. ठीक है, दिस फॉर्मूला वी ऑलरेडी रेड. Final velocity minus initial velocity upon total time taken. That is what they have written. Final velocity is omega 2 at time t2. Initial velocity is omega 1 at time t1, and the time taken for change is t2 minus t1. So delta omega means total change in velocity upon total time taken is the formula for average angular acceleration. ठीक है, SI यूनिट. अब ये सिंपल सी बात है. एक्सेलरेशन की SI यूनिट क्या होती थी? मीटर पर सेकंड स्क्वायर ना, मीटर पर सेकंड स्क्वायर होती थी थर्ड चैप्टर में. यहाँ पर क्या होगी? एंगल के बारे में बात हो रही है. एंगल मेजर होते हैं रेडियन में, तो यहाँ पर होगी रेडियन पर सेकंड स्क्वायर. ठीक है, तो SI यूनिट फॉर एंगुलर एक्सेलरेशन विल बी रेडियन पर सेकंड स्क्वायर. What is the last point in angular acceleration? Instantaneous angular acceleration. What is the meaning of instantaneous angular acceleration? Angular acceleration at a particular instant of time. Angular acceleration at a particular instant of time. That is the instantaneous rate of change of angular velocity. How do you calculate angular acceleration at a particular instant? You just differentiate the velocity at a particular instant of time. If you differentiate the velocity, you will get the change in the velocity, and that is at a particular time, and that is your angular acceleration at that particular time. ठीक है, सिंपली क्या करना है, जो आपको इंस्टेंटेनियस वेलोसिटी दे रखी है उसको टाइम के रिस्पेक्ट में डिफरेंशिएट कर दो. आपको देखना ही है कि जिस टाइम पर आपसे एंगुलर एक्सेलरेशन पूछ रहा है उस टाइम पर आपकी इंस्टेंटेनियस वेलोसिटी कितनी चेंज हो रही है. तो जितनी चेंज हो रही है वो डिफरेंशिएशन करके निकल जाएगी. ये सब चीजें आपने करी गई हैं, मैं बार बार रिपीट क्यों कर रहा हूं इसको. ठीक है, सो इंस्टेंटेनियस एंगुलर एक्सेलरेशन अल्फा इज इक्वल टू डी ओमेगा बाई डी टी, चेंज इन इंस्टेंटेनियस एंगुलर velocity. What else? Net or total acceleration. Okay, I'll come to ये net और total acceleration क्यों है. Net acceleration या total acceleration का मतलब क्या है? What is the meaning of total acceleration? I've already told you that in circular acceleration there are two components of acceleration. One is your tangential, which is along the tangents of the circle, tangential, and the other one is angular acceleration. So these are two types of acceleration, angular and tangential. So net or total acceleration will be sum of both of these. You have to add both of these, but acceleration is a vector quantity. Acceleration is a vector quantity, so you have to add them vectorly. ठीक है ना. अब भाई नेट का मतलब क्या होता है? अगर मैं आपसे बोलूं आपके घर में 20 चॉकलेट रखी हैं, you have 20 chocolates at your home, 10 chocolates are in one room and 10 are in separate room. So what is the total number of chocolates? You will say sir 20, because you have added. If I'm asking total number of chocolates inside your home, that will be 20. But if I'm particularly asking total number of chocolates in your room, that will be 10. Okay, because I have kept only 10 chocolates in your room. तो डिफरेंस देखो आप, अगर आपसे सिर्फ टेंजेंशियल एक्सेलरेशन पूछेगा तो आप टेंजेंशियल बताओगे. If they are asking you only angular acceleration, then you only tell them angular acceleration. But if they are asking you net acceleration or total acceleration from you, will add both of them vectorally, because acceleration is a vector quantity तो vectorally add करोगे. वेक्टरली कैसे ऐड करते हैं किसी क्वांटिटी को जिसके दो कंपोनेंट हो. सपोज करो एक्सेलरेशन एक वेक्टर क्वांटिटी है जिसके दो कंपोनेंट है, एक सेंट्रीपिटल एक सेंट्रीपिटल अब सेंट्रीपिटल टेंजेंशियल. अभी देखो, आप एंगुलर समझ लो तब तक इसको, ठीक है. इसको आप एंगुलर मान लो कि सर एंगुलर की बात करें सेंट्रीपिटल की जगह, वैसे इन्होंने सेंट्रीपिटल के टर्म्स में लिखा हुआ, मतलब इसमें स्लाइड में दिया हुआ है. वेक्टरली किसी भी कंपोनेंट को कैसे कैलकुलेट करते हैं जिसके दो कंपोनेंट हो, ऐसी क्वांटिटी को कैसे कैलकुलेट करते हैं. स्क्वायर रूट के अंदर उसके दोनों कंपोनेंट्स को स्क्वायर करके ऐड करते हैं. सो हाउ डू यू कैलकुलेट द नेट और टोटल एक्सेलरेशन इनसाइड द स्क्वायर रूट? यू ऐड द square of the individual components. ठीक है, you will add this square of the individual components inside the square root. That is how you calculate the total acceleration. Now this slide is in respect to centripetal. या देखो AC लिखा हुआ है ना, ये सेंट्रीपिटल एक्सेलरेशन को डिनोट करते हैं ऐसे AC से. तो ये स्लाइड सेंट्रीपिटल एक्सेलरेशन के रिस्पेक्ट में, बट आप मान लो कि सर एंगुलर एक्सेलरेशन के टर्म में बात कर रहे हैं. डिफरेंस कोई नहीं आता उससे कोई फर्क नहीं पड़ता. ठीक है. नाउ अच्छा, दिस इज if you are able to draw this analogy, let me write this in the separate page. आपको ये अगर ये समझ में आया तो what I will summarize for you. I will summarize like this. What is alpha? Angular acceleration. Average angular acceleration will be omega 2 minus omega 1. That is the main highlight. How do you calculate average angular acceleration? Net change in angular velocity upon total time taken. ठीक है, so this is the first important highlight of the slide. The second thing is SI unit is radian per second. Radian per second square, not second. ठीक है. And if they have given you angular velocity, okay, angular velocity is given to you and they are asking you angular acceleration, तो कैसे calculate करोगे? If angular velocity is given to you and they are asking, and you have to calculate angular acceleration using it. If angular velocity is given and you have to calculate एंगुलर एक्सेलरेशन यूजिंग इट. एंगुलर एक्सेलरेशन आपको कैलकुलेट करना है, एंगुलर वेलोसिटी आपको दी हुई है, इससे कैसे कैलकुलेट करोगे? थर्ड चैप्टर में कैसे करते थे? वेलोसिटी से एक्सेलरेशन बेटा इंटीग्रेट करते थे, याद है? वेलोसिटी से व्हाट वी यूज्ड टू डू इन थर्ड चैप्टर फॉर कैलकुलेटिंग एक्सेलरेशन, यूज्ड टू इंटीग्रेट. व्हाट वी यूज्ड टू इंटीग्रेट? Do you remember these formulas from v1 to v2? dv is equals to a dt from time t1 to t2. These are the formulas of third chapter. Will not exact same thing will happen here. If angular velocity omega is given to you, you simply write d omega, put the limits omega 1 to omega 2, the limits will be given to you. Okay, because you have to calculate angular acceleration, and angular acceleration is between two velocities, so the two limits will be given to you and the time period will be given to you. So simply write alpha dt and write the time limits t1 into t2. So if you will calculate angular acceleration through angular velocity, this is the method. You have to integrate angular velocities, okay, just like you did in the third chapter. Okay, this formula you have already done in the third chapter. So based on this, it's the exactly same, just what is difference is terms are different. Here angular velocity is being integrated with respect to time. Angular velocity is being integrated with respect to time to calculate what? To calculate angular acceleration alpha. Okay. And how do you calculate angular acceleration? If the angular velocity is given to you, simply differentiate. If the angular velocity is angular acceleration, if you want to calculate angular acceleration, then you can simply differentiate angular velocity. And what else? Question दें क्या? Okay, one more thing. I'll draw a small box here. In uniform circular motion, this is only valid in uniform circular motion. Uniform circular motion. Speed is constant. You can see this. What do you understand by the word uniform? That the speed is constant. Okay. So if the speed is constant, we used to say magnitude of velocity is constant. Magnitude of velocity is constant. How do we say this in the term of angular terms? We say magnitude of angular velocity omega is constant. Okay. So always remember, in uniform circular motion, UCM means uniform circular motion. Magnitude of angular velocity. This means magnitude of angular velocity. Magnitude of angular velocity remains constant. Okay. So now you know the summary of the three things. If the different velocities are given to you and you want to calculate angular acceleration, then you have to simply calculate them. Average angular acceleration, simply you can calculate by calculating change in velocities over a period of time. Okay, and if the angular acceleration is given to you, okay, and they are asking you angular velocity, then you can integrate the angular acceleration to calculate the angular velocity. And if angular velocity is given to you and they are asking angular acceleration, then you can simply differentiate. Let me just ask you, कुछ समझ में आया? सब ऊपर से चढ़ा गया जो मैं बोलता रहा इतनी देर तक. हिंदी में समराइज करूं एक बार. समराइज करूं हिंदी में. कैसे समराइज इन हिंदी? देखो, एवरेज एंगुलर एक्सेलरेशन आपको निकालना हो तो चेंज इन वेलोसिटी अपॉन टोटल टाइम टेकन. चेंज इन वेलोसिटी देखो आपको दो ओमेगा दिए हुए हैं, एक ओमेगा 1 एक ओमेगा 2. एंगुलर वेलोसिटीज एट टू डिफरेंट टाइम. ठीक है, तो ओमेगा 2 माइनस ओमेगा 1 फाइनल वेलोसिटी माइनस इनिशियल वेलोसिटी जैसे अपन करते थे अपॉन T2 माइनस T1 टोटल टाइम निकालने के लिए जितनी देर में चेंज आया. तो इस तरह से आप एवरेज एंगुलर एक्सेलरेशन निकाल सकते हो. ठीक है, अगर आपको भाई एंगुलर एक्सेलरेशन दिया हो और आपसे बोले कि एंगुलर वेलोसिटी बताओ, तो एंगुलर एक्सेलरेशन को इंटीग्रेट करके टाइम के रिस्पेक्ट में आप एंगुलर वेलोसिटी निकाल सकते हो. और इसका ठीक उल्टा, अगर आपको एंगुलर वेलोसिटी दी हुई हो और आपको बोले कि आपको एंगुलर एक्सेलरेशन कैलकुलेट करना है, तो आप एंगुलर वेलोसिटी को डिफरेंशिएट कर सकते हो विद रिस्पेक्ट टू टाइम टू कैलकुलेट एंगुलर व्हाट एक्सेलरेशन. एंगुलर वेलोसिटी को डिफरेंशिएट करके आप एंगुलर एक्सेलरेशन निकाल सकते हो. और अगर एंगुलर एक्सेलरेशन दे दिया और पूछा एंगुलर वेलोसिटी बताओ, तो उसको एक्सेलरेशन को इंटीग्रेट कर सकते हो विद रिस्पेक्ट टू टाइम टू कैलकुलेट एंगुलर वेलोसिटी. ये कुछ फॉर्मूलाज थे जो मैंने समराइज कर दिए. एक क्वेश्चन कर देते हैं आपके लिए, मतलब दे देते हैं आपको. ठीक है, यू विल फील बेटर. सर बेटर तो कुछ फील नहीं हो रहा, क्लास भी आज बोरिंग बोरिंग सी लग रही है. न्यूटन्स लॉ ऑफ मोशन स्टार्ट करने का टाइम आ गया है, लेकिन एक क्वेश्चन कराएंगे उसके बाद. अरे टाइम तो नहीं हो गया है? सपोज टाइम भी खत्म होने वाला होगा ना, 1 घंटा होने वाला होगा. एक क्वेश्चन करो तब भी, कोई बात नहीं. सेंट्रीपिटल एक्सेलरेशन भी तो कराना है अभी आपको, लास्ट टॉपिक इस चैप्टर से. बहुत छोटा सा टॉपिक है, डोंट वरी. ये चेंजेस है. रोटेटिंग व्हील चेंजेस एंगुलर speed. A rotating wheel is changing its angular speed from 1800 rpm to 3000 rpm in 20 seconds. What is the angular acceleration assuming it to be uniform? क्या दे दिया मैंने क्वेश्चन में? लेट मी एक्सप्लेन द क्वेश्चन टू यू. I've given you a rotating, I've given you the change in the angular speed. Okay, a wheel is rotating and the rotating wheel is changing its angular speed from 1800 rpm to 3000 rpm. And I've also given you the time. Okay, the time for which time taken for this change to occur, it is 20 seconds. And what I'm asking you, angular acceleration. Okay, assuming to be uniform, that the angular acceleration is uniform and it is not changing with time. Okay, so just calculate the angular acceleration using these data. The question is simple. Okay, the trick lies in this three letters rpm. Okay, the trick lies in this. If you know what is the meaning of rpm, I will tell you what is the meaning of rpm. If you will not know, I'll give you a hint. rpm full form I'll give you, rotation per minute. Okay, अब solve करो. It's just a simple trick question. Very simple trick question, but simple है. Rotation per minute is the full form of rpm, and the trick in the question lies in the word rpm. Okay, so just think on this and try to solve it. Otherwise, I'll tell you the how to solve it. Don't worry. I'll tell you that. Definitely, I'll tell you that. But try करो. Guys, are you able to solve it? 6.28. 6.28. One answer. What about others? Nobody's trying. Shall I tell you the answer then? कोई और भी ट्राई करो. सिर्फ मलिनी ट्राई करेगी क्या? सर हमें तो उतना ही समझ में नहीं आया. मलिनी ने शायद लगता है आंसर सही निकाला है. मलिनी, मुझे आपका आंसर सही लग रहा है. चलिए देख लेते हैं. लेट्स सी हाउ टू सॉल्व दिस क्वेश्चन. सी, RPM means rotation per minute. Rotation per minute. Can you recall the unit of frequency? What was the unit of frequency? Revolution per minute. So revolution and rotation are same words. So this is what is given to you is the frequency and not your angular speed. Okay, what is given to you is frequency and not angular speed. This is the catch here. यही इस क्वेश्चन में कैच था कि आपको दी हुई है फ्रीक्वेंसी और आपको बोला है कि एंगुलर वेलोसिटी में चेंज दिया है. यही आपको समझना था कि क्वेश्चन में थोड़ा सा घुमाया है. They have given you change in frequency and they are claiming that they have given you angular speed. Okay, so that's what you have to pick up from the SI unit, revolution per minute or per second. Anyways, they have given you frequency. Now, how should you solve it? You should first of all, using this frequency, you have to calculate the original angular speed which they have not given to you. Okay, so how will you calculate this? Omega is equals to 2 pi f wala formula. Okay, so frequency for, let me write frequency for in the first case, okay, for 1800 rpm, f1 will be what? 1800 upon 60. Okay, why 60? Because they have given you per minute. PM means per minute, but we need in seconds. Okay, so it will be 18, 600 and 6 3 is 18, so 30. So 30 is your frequency in the first case. Frequency in the second case is 3000 upon 60. So again 0 and 0. So in this case it is 50. Hai 6 5 is 30, 50. 50. Now you have to calculate what? Angular acceleration. Angular acceleration alpha is change in angular velocity, omega 2 minus omega 1 upon total time taken, which is 20. How will you calculate omega 2 minus omega 1? Omega is equals to 2 pi f. If you remember this formula, you can easily calculate this omega 2 minus omega 1. So you simply have to write 2 pi 30 minus 50 minus 30, not 30 minus 50, 50 minus 30. बड़े में से छोटा minus करते हैं. Okay, you have to subtract smaller number from a bigger number. So 2 pi 50 minus 30 upon 20, which is nothing but कितना आ जाएगा ये? 50 minus 30 is 20. So 2 pi into 20 upon 20. 20 will get cancelled. The answer will be for alpha will be 2 pi radian per second square. If you put the value of pi, you will get 6.28, which is the correct answer of Malini. Okay. So this was the last question for today. I hope you understood the solution, and we'll meet tomorrow, and we'll discuss the for centripetal acceleration.